Hello everyone, my name is Ali Berke Akçay. I am a first year electrical and electrical engineering student at Bilkent University. Today I will represent you my lab project experiment for the Physics 101 course. The objective of my experiment is to observe how mass distribution affects the moment of inertia and to also compare two methods of measuring the moments of inertia. With this experiment, we can see how accurate theoretical formulas represent real-life scenarios. For the first method, we will measure each object's mass and radius and use their theoretical formula. For the second method, we will roll them down an incline and derive their moment of inertia from their acceleration. When we roll down a circular object, the friction force applies some torque to it. Therefore, the acceleration of this object depends on its rotational inertia as well. This inertia is called the moment of inertia and it is defined as the following. Also, we will acknowledge the existence of friction, but ignore its effect on energy loss for this experiment. Now, we will derive the necessary formulas for this experiment. In a hollow cylinder, all the mass is distributed evenly at its rim. Therefore, the moment of inertia is the following. For the solid cylinder, we will use the cylindrical shell method. The steps are as the following. For the hollow sphere, we will think of it as infinitely many thin rings and use their polar coordinates. The steps are as the following. For the solid sphere, we will approach it as infinitely many disks stacked on top of each other. The steps are as the following. To derive the moment of inertia from acceleration, we will use energy conservation. The steps are as the following. Now that we got all the necessary formulas, let's move on with the procedure. The equipments used in this experiment were the following. Initially, I measured the mass and the radius of each object, as well as the length of the incline, and noted them down. Then, I used the formulas to get their moment of inertias. After that, we started performing the rolling down motions. Each trial was recorded with a slow motion video, which was used to measure the time of each motion. Each motion was repeated 5 times for each object. You can see the motions of our objects and their respective data. After we were done with the motions, we calculated the error percentage of each object. Here are some graphs to better visualize our results. From this experiment, firstly, we can clearly observe that the definition formula and data from real-life experiments show the same trend. The more mass distributed further from the axis of rotation, the more rotational inertia. Secondly, we can see that the error between our two methods were relatively small. However, not negligible for most scenarios. Now, I would like to discuss some potential causes for this error. Firstly, our objects did not have perfectly smooth surfaces. Each one of them had some deformations. This was especially visible for the solid sphere, which had a relatively high error. Secondly, our hollow cylinder had a considerable thickness, which we completely ignored in our first method of measuring the moment of inertia. Therefore, it got the highest error among all. Thus, we should ignore this data when we are making conclusions from this experiment. Thirdly, we ignored friction's effect on energy loss. However, it did cause some energy loss. Additionally, our method of determining the duration of motion from a slow motion video caused some uncertainty, since it was difficult to detect the exact frame the motion started at. Since the moment of inertia is proportional to the square of time, this uncertainty had a considerable effect on our error. Lastly, we assumed the gravitational acceleration constant to be 9.8 meters per second square. However, it is actually not constant and varies around the world and according to our altitude. That was my Physics 101 lab project, with its theory, data, conclusion, and error discussion. Thank you all for watching.